Well, hello there, geometry. It is the video before a test, and so today is going to be about getting you ready and doing a bunch of problems that remind you how to do the stuff that we have been doing since we started actually studying math in this class. So here's a little warm-up for you. How do you study? Do you do assignments? Do you not study? Do you look over some things but you don't have a real strategy? Or is it all about the notes with you? Take a moment and decide which of those is you, or maybe you have some other method. All of these are things that I have heard from students. Some students, the word study is important here. How do you study? Some kids just do assignments. And that's not a great way to study, because doing the assignments is what you do to practice. When you study, studying should be about reviewing information. And so if you said that I do the assignments, that's really something that should be done before you study for a test. Part B, you don't study? Okay, but I suggest that you do, especially when it comes to math class. Part C, I look over some things, but I don't have a real strategy. This is very common because oftentimes we just don't even tell you how to study. We just say, go study, and you're supposed to make it up on your own. Really, the correct answer to how do you study should be, it's all about the notes, because you've already done the assignments. A great strategy for studying for a test is to open your notebook and to quiz yourself on the questions that you wrote, and to write summaries or reread summaries or rewrite those notes so that they're more clear, or answer additional questions or write additional questions or add to your summaries. Really digging into your notes is what study is. Studying means that you're getting back into that information for the fourth or fifth time and really cementing those ideas in your mind. So how do you study? Friends, studying is all about the notes. So speaking of notes, how do you dig into them? Well, you check over your notes and write any summaries that you've missed, or maybe you add to those summaries. You write questions on pages that have none, or you write more questions on pages that do. Maybe you cover up your notes and you use the questions that you wrote to quiz yourself. You now have what amounts to a bunch of flashcards if you've created these notes in a way that lets you do that. And then you also update your table of contents to make sure that you haven't missed something. So far, these 11 items are the 11 items that should be in your table of contents. If you're missing any of these, you might want to go back to the Google Classroom and make sure you add to those notes. Make sure you have this information. Yeah, if you're missing any of these, go back, watch the video, take some notes. So now that we have gotten the idea that we need to study, that's the kind of thing that you end up doing on your own, but it's also really helpful to get ready for a test if a teacher kind of runs through the ideas with you. So that's what this video is about. I'm going to do like one problem on each concept just to kind of remind you of what you might see on the test. So the first thing that we did in this class was operations with fractions. And we did things like multiplying fractions. And we remembered that multiplying fractions is just a matter of multiplying straight across the top and straight across the bottom, and then simplifying if need be. We also talked about dividing fractions. And what we remember from dividing fractions, hopefully, is that you keep it, change it, and flip it. And so in order to divide fractions, what you do is you keep the fraction the same, the first one. You change the division to multiplication, and then you flip that second fraction over. These are saying exactly the same thing, and there's all kinds of great math that could prove this to you, but we don't really have time for that. Now it's a multiplication problem, so you multiply straight across the top and straight across the bottom. And there you go. That's already reduced, and you're good. We also talked about adding fractions. And I talked about a technique that I use that I'm going to do kind of on a different part of the board. I take horizontal addition fractions and subtraction too. These are kind of the same thing. And I stack them. And I create for myself some space for my answers. And then I go about finding a common denominator. Notice that with multiplication and division, you didn't have to find a common denominator. It's only with addition and subtraction of fractions that you do. And the easiest way to find a common denominator is to multiply the denominators in the original fractions. And so 2 times 3 is 6, and we'll use 6 as our common denominator. And now we want to remember also that our common denominator stays even with the answer. And so that is a great thing to do too. Go ahead and write that common denominator in your answer so you won't forget. Now it's a matter of changing the 1/2 and the 2/3 into equivalent fractions that have 6 as your denominator. And the way you do that is think about how you got that 6 in the first place. Well, in order to get to that 6 by multiplying, I did 2 times 3. And what you do to the bottom, you have to do to the top. And so you're going to also multiply the 1 by 3. 1 times 3 is 3. So now we have an equivalent fraction. And then on the bottom one, 3 times 2 was 6. And so we have to do the same thing to the top, 2 times 2, and get 4. And now we are completely done with worrying about those fractions. We have expressed them as equivalent fractions with a common denominator. And now we just add the numerators. 3 plus 4 is 7, and that is our final answer. Now the only thing that would be different with subtracting would be subtracting those final answers. And so you'd have 3 minus 4, and so if you were subtracting, you'd have -1/6. Alrighty? So this is operations with fractions. There's things to remember for each type of each operation that you're doing with fractions, and that's what makes it kind of tricky, because you have to remember different things. But hopefully these techniques that I've talked to you about help you get through problems like that. The next thing we talked about was the order of operations, and I gave you what I call the better order of operations, and it looks a little different than what you might have seen in the past. And what GEMDAS means to me is that the first thing I do is take care of the grouping symbols. These could be parentheses like you're used to, but also brackets and fraction bars and all kinds of stuff group numbers together. So you're going to be taking care of those things first. And then the second step is the one that you're used to, which would be to take care of the exponents. And then there's really only 4 steps in the better order of operations, because the better order of operations tells us that we have to multiply and divide in order from left to right. If it's division first on the left, then you divide first. If it's multiplication, you multiply. And you go all the way through from left to right and take care of all the multiplying and dividing in one step. And then the last, or 4th step in the better order of operations is addition and subtraction in order from left to right. And so if we're going to solve this problem right here, first of all, we don't have enough room on this page, so I wonder if I can grab it and just pull it down. Oh, look at that. Will you look at that? And now I'm going to create a longer page. Oop, there we go. And now we can actually solve this. So the better order of operations says that we have to take care of the things that are inside the grouping symbols. And you go to the innermost grouping symbol and you take care of all the order of operations inside that grouping. And so right here is where we're going to start. So in that first step, we're just going to rewrite everything that we're not taking care of. So 4 plus 2, and then a bracket, 35 minus, and then inside these parentheses, notice that we have an exponent. And so we're going to have to deal with that exponent first. We have 11 plus, and then 8 squared, or 8 times 8, is 64. That ends the parentheses and the brackets. Now we haven't gotten rid of that those parentheses yet, and so we have to stay there until they're gone. So we still have 4 plus 2 times 35 minus, and now what is 11 plus 64? Well, it's 75. And now we have gotten rid of those parentheses because we took care of everything inside. But we still have another set of grouping symbols. We've got these brackets, and so we got to take care of what's inside of there. And we have 4 plus 2 times 35 minus 75. And that is negative 40. Now the interesting thing about grouping symbols is that once you've done everything inside, sometimes they end up becoming multiplication symbols. And so the purpose of the brackets has now changed, and we can move to the next step. We've taken care of our exponents already because that came when we did those parentheses. So we really are on the multiplication and division in order from left to right step. Now it would be very tempting, but wrong, to add 4 plus 2 right now and get 6 times negative 40. And a lot of people make that mistake. But notice that you are adding, and you can't add before you multiply. And so really we still have this 4 plus because we can't do anything with it yet until we do 2 times negative 40. 2 times negative 40 is negative 80. So really what we have is 4 plus negative 80, and I've put some parentheses there because I wanted to contain the negative sign. I chose parentheses instead of brackets because they're kind of doing the same thing. It can be a little bit confusing sometimes, so be careful. This is the same thing as 4 minus 80. You could write it like that. And what is 4 minus 80? Negative 76, right? So then when you finally get one number, you know you're done. The better order of operations, if you pay attention to it, can step you through problems like this. Make sure you remember especially that the multiplication and division happen in order from left to right, and then your addition and subtraction in order from left to right. Don't make the mistake of adding before you multiply. All right, and then we started talking about multi-step equations. This is where the algebra started cropping up again. And the order of operations still pertains here. It pertains in all math problems. It's, the rules of math. But now we need to be able to solve for a variable. And in this case, we have a k. And so we have to think about getting rid of the parentheses first. But looking inside the parentheses, we have unlike terms. We have 4k minus 4. And so we can't just do anything with them. We can't get rid of the parentheses by operating inside the parentheses. And so we need to use another thing that you've heard about in the past, the distributive property. If we distribute this 8 into these parentheses, it will do that job of getting rid of the parentheses in the first step. And so our first thing is 8 times 4k, which would be 32k, minus 8 times 4, which is 32, equals negative 5k plus 116. There's nothing we can do there, and so we're just going to bring it down. All right, now we have to start thinking about algebra at this point, because looking at the left side of the equation, we have unlike terms. They can't be combined. On the right side of the equation, we have unlike terms. They can't be combined. And so we want to be clever here and start rearranging our problem. This is where the creating clever cancellations step of algebra comes in. You're going to want to try to get rid of things and move your variables together and your non-variable terms together. At this point, there's actually 4 different things you could do correctly to take the next step. You could subtract 32k from both sides. You could add 32 to both sides. You could add 5k to both sides, and you could subtract 116 from both sides. All 4 of those things are a correct next step because they create a clever cancellation. Personally, I prefer to take care of that negative 5k first. And the reason why is because I know with experience that what that does is moves my variable terms over to the left, and I like it when they're over there. That's the only reason why I do it that way. So I'm going to add 5k to both sides. This is a reasonable step as long as I combine like terms and I don't try to add 5k to this negative 32. That creates this cancellation right here, and I have 32k's plus 5k's, which is 37k, minus 32 equals 116. And now there's really only one thing to do, and that would be to add 32 to both sides. And these cancel. And you have 37k equals 116 plus 32, or 148. And then the last step would be to divide both sides by 37, because you want to create the cancellation that occurs here. K is by itself. And what is 148 divided by 37? Well, I don't know off the top of my head. I'm going to plug it into a calculator. 148 divided by 37 is 4. And we have found the answer to our problem. Multi-step equations are just kind of keeping track of the 2 steps that algebra really is: creating clever cancellations and doing the same thing to both sides. If you remember those 2 things, you can do almost any algebra problem. And then we started talking about geometry, and we started with some vocabulary. We have words like line segment, endpoints, ray, intersection, collinear, coplanar, congruent, midpoint, and bisector. And we have those words defined in our notebooks. That was an assignment that I had you do with a glossary. These are important words in geometry, and you should know what they are. I'm not going to take the time in this video to go ahead and define them, but if you don't know any of those, it would be worth it to go back to the geometry vocabulary assignment and review the names, these words. And there's a couple of glossaries in Google Classroom that can help you. When we started talking about geometry symbols, we started talking about using these words and pulling information out of diagrams. And so when we look on the left, we have 3 diagrams, and we want to first name each midpoint and the segment it bisects. It is important to know what a midpoint is so you can name it. A midpoint is a point that cuts a segment exactly in half, or creates 2 congruent segments. Congruent means that they have the exact same measure. So if we look at segment CD right here, we see that on either side of F, each part is 2 centimeters. That's the same length. Those 2 segments are congruent, and so F is a midpoint. And the segment it bisects is CD, with a segment on top. F bisects, yes, what I should do, I should write it all out. F bisects CD. Okay? Now looking at HL, there's no point on there that bisects anything. That little tick mark on there is just telling us that it's congruent to something else. So HL doesn't have any midpoints. Neither does HJ for the same reason. And oh, by the way, going back to this one, we don't know anything about whether or not F bisects EG. It looks like it does, but there's no markings to tell us that, and so we cannot assume it. So the next one we look at is JL. Notice that on either side of JL are these markings that say that the distance between JK and LK are exactly the same. They are congruent. And so K bisects JL. And then in the last figure, N appears to be right in the middle between M and P, but there are no markings to tell us that that is the case. And so we can't assume anything about point N. We really don't know if it's a bisector. Now when we go back to B, go on to B, we're going to be naming all of the congruent segments. These are the segments that have the same measure or have markings that tell us that they are the same. And so back to this figure, we see the 2 centimeters on both places, and we can say that segment CF is congruent to segment DF, and we would write it like this: CF is congruent to DF. We'd like to say that EF is congruent to GF, but there's nothing that tells us that, so we move on to the next figure. Now notice that HJ is marked with one little tick mark, and HL is marked with one little tick mark, and that's telling us that those segments are congruent. And so we can say that HL is congruent to HJ. That's what those little markings mean. Now we also have the same kind of thing here. But now there's two little markings, which means that JK is congruent to LK. And then in the last figure, we don't know anything about what's going on in that figure. We see 3 points and a segment that connects them, but no markings, and so we can't make any assumptions. Oh, look what I forgot. Boom. So that's it. This is how you use geometry vocabulary and geometry symbols to pull information out of figures and write it accurately. After that, we moved on to a little bit deeper way of looking at geometry notation. Very commonly with problems like this, you're going to have a figure. Right here we have this plane that's a parallelogram that's sort of shaded blue. We've got an M here with no dot next to it. That means that's the name of the plane. We can call it plane M. We have a couple of lines. We have letters sitting next to the lines with no dots, which means those are names of the lines. And so we can proceed with this, having taken all that information in. Number 1 says, give another name for plane M. Well, planes can also be named by 3 points that are on that plane. So I could call plane M, I could call it X, N, Z if I wanted to. That's another name for that plane. Any 3 points on that plane will name it. Name a line in the plane. There is only one, and you could call it XY, you could call it YZ, you could call it XZ, or you could just call it line G. All of those would be acceptable. But if you called it, for example, XZ, you'd have to be sure to put a line symbol on top because it's a line and it needs to come with that symbol. Name a line intersecting the plane. Well, that is going to be this line here. And we could call it PY, we could call it YP, we could call it line H. All of those things would be acceptable. All right, name 2 rays. A ray has one endpoint and then a point that it goes through. So for example, we could name this ray, and what we would call it is YZ with a ray on top. And that ray on top tells us that the end point is Y and it goes out through Z. There are a lot of rays in this figure, and so you could pull a lot of possible rays out of this. A pair of opposite rays. Opposite means that they go in exactly opposite directions, and so YX is opposite of YZ. And you could write YX and YZ are opposite rays. And then if you wanted to name a point that was not on the plane, you'd have to find one that obviously isn't on that plane. And I think the only choice here is point P. So there you go. That's how you answer questions like this, using that vocabulary, using those symbols, making some assumptions about what's happening with this figure, and picking up the names of things. Then we moved on to translations, and we talked about translation rules and how we can read them. This says graph quadrilateral ABCD with those vertices and its image after a translation. Its image is going to be the object after it has been moved. So here is our quadrilateral. Very badly drawn, but you get the idea. And we have this translation rule. And what this translation rule says is take every point X and Y and move it 3 units to the right and 1 unit down. And so you just pick up each of the vertices and do exactly that. So I'll start with A. 3 units to the right, 1, 2, 3, and 1 unit down gives us what we call A prime. We call it A prime because we want to be able to tell the difference between the pre-image and the image object. Same thing with B. We're going to move it over 1, 2, 3, and then 1 down and get B prime. C, same thing, 1, 2, 3, and 1 down gives us C prime. And then D, 1, 2, 3, and 1 down gives us D prime. And now be sure you connect those dots, friends. And there you go. a translated figure, the pre-image, ABCD, and the image, ABCD prime. And then we started talking about how you could put translations together for what was called a composition. And this is essentially moving an object one time, and then taking that new object and moving it again, and then figuring out what the composition rule is. So we've got this triangle, and the first translation is going to be 1 unit to the right and 3 units up. So let's do that. A goes 1 unit to the right and 3 units up, 1, 2, 3, and ends up here at A prime. B goes 1 unit to the right and 1, 2, 3 units up for B prime. And C goes 1 unit to the right and 1, 2, 3 units up for C prime. And this was our first translation. Now from that point, we're going to take our second translation. This time we go 3 units to the left and 5 units up. And so A goes 3 units to the left, 1, 2, 3, and 5 units up, 1, 2, 3, 4, 5. And this time we call it A double prime because we have to keep track of the names of these objects. B prime goes 1, 2, 3 to the right and 1, 2, 3, 4, 5 up to get to B double prime. And then C goes 1, 2, 3, 1, 2, 3 to the left and 1, 2, 3, 4, 5 up for C double prime. And now we have that new triangle. And that's what a composition looks like on a graph. In order to get the composition rule, you could just count from your original object, your pre-image, all the way to that final image, the double prime. And you could just say, well, A went 1, 2 to the left, and 1, 2, 3, 4, 5, well, I count in just a second. 1, 2, 3, 4, 5, 6, 7, 8 up. And so what that suggests that our rule would be x minus 2, y plus 8. But there's a trick. You could also just write it like this. That part always comes first. And then you could say 1 minus 3, which is that negative 2. And then y is 3 plus 5, or 8. And there's your composition rule. There's a couple of ways you can do it. So that's what compositions are. They're a combination of movement ending up with a rule that tells us how to get from the very first place to the very last. All right, and I think this is the final thing that we talked about before we move on to taking a test. There are things called coordinate rules, and when we're talking about reflections, we're always talking about reflecting over a particular line. And so the first thing to do is understand that lines, equations of lines, sometimes look like this. And you can reflect over them. But sometimes you need a rule for that, because this line has a slope. If the lines are vertical and horizontal, you can really just count, because you have all the boxes on the grid. There's no reason why you can't count. But if you have a line that's sloped, you're going to have to use a rule. Now, what I mean about this line being sloped is this equation right here says that every point on this line, they have the same value except opposite signs. And so things like 1, negative 1, and 2, negative 2, and 3, negative 3. And then you also have negative 1, 1, negative 2, 2. And this creates a line. Oh, come on, Miss Waite, you can do it. Whoa, no, that's terrible. All right, good enough. That is the line y equals negative x. And we can't predictably count to this line because it has a slope, and so we have to use a rule. And here I have all of the rules. Now, normally these have arrows in between them. So there you go. And we just have to pick the right rule. And if we're going to reflect in line y equals negative x, we're going to use this rule right here. And the rest of them we don't care about because they don't give us what we want. We picked the correct rule. What this rule says is take every point, flip them, and turn them negative. So what we need to know are the coordinates of each point. That's what's next. So let's call this one, even though it's very badly placed, point A, and here's B, and here's C, and here's D. Let's find out the coordinates of these points. So A lives at negative 1, 2, 3, 4, positive 1, 2, 3, negative 4, positive 3. B lives at positive 1, positive 1, 2, 3, 4, 5, so 1, 5. C lives at 1, 2, 3, 4, 1, 2. And D lives at 0, negative 1, 2, 3. Okay? Now that we have those coordinates, we can just run them through the rule. For example, A lives at negative 4, 3. So we know that A prime lives at, switch them, and turn them to the opposite. So 3 becomes negative 3, and negative 4 becomes 4. And that's where A prime is going to be. B prime, B that lives at 1, 5, goes to B prime, which would be flipped and turned opposite, so negative 5, negative 1. C, which lives at 4, 2, would go to C prime, which is at negative 2, negative 4. And then we have D, I'll squish it in here. D has, let's see, 0, negative 3. And that goes to D prime, which is at positive 3, 0. 0 is just 0 because it's its own opposite. So now we can graph these new points. And that is going to be our new image. So negative 3, 4, negative 1, 2, 3, positive 1, 2, 3, 4 is where A prime lives. B prime is at negative 5, negative 1, so negative 1, 2, 3, 4, 5, negative 1. Here's B prime. C is at negative 2, negative 2, negative 1, 2, 3, 4. Here's C prime. And then D prime is at positive 3, 1, 2, 3, 0. And here you go. And that takes that object and flips it over the line y equals negative x. It's a bit of a process, but you can do it if you remember the rules. So that's it, friends. That's a quick review of the kinds of things you might see. Before Wednesday, I suggest that you go over your notes and finish any assignments. Find out where your weak spots are. Review your notes. Watch those videos again. Come to my office hours and let's talk about stuff. You know, Google's a great place to look up math stuff. If you don't understand something, Google it. But really, also, don't spend all night studying. Get some rest. A rested brain is a much more able brain. And then on Wednesday, this test is going to show up on the Google Classroom. And so you'll take it and you'll have some time. It's not like it's just going to show up and then you only have a few minutes to do it. I'm going to leave it open for a few days so you have some time to get that done. Haven't quite figured out that part, but I will. Most importantly, believe you can, friends. If I can do this, you can too. I'm not a genius, but I work hard and I do what I'm asked to do, and I hope that you would do the same thing. You got to believe that you can so that you can. All right, you guys, I hope you have a great day, and I'll talk to you soon. Bye.